Hello friends, we start with our next problem solving session. If you have still not subscribed, comment and share my channel, please do it, because once you subscribe it will be more easy for you to go through my all videos in a sequential manner. So please subscribe my channel for better understanding of this subject. Okay, so as per my previous video, we have already completed the concepts of maximum power transfer theorem. Now we start with the numerical problems. Okay, so that is our problem solving session, and we start with our first problem. So friends, this is our first problem. Okay, so this is our first problem. This problem was asked in GATE examination. Okay, this was a problem of GATE 2 marks question. In this question, you have to find the value of I, which is mentioned here as this, and the value of R, which is mentioned here as this. Okay, so these two values you have to find, this value and this value. Now please try to understand what is the condition of this network. Here this is a network, and across the terminal AB, this entire is considered as a load, not R. R is not load here. This entire network is connected at terminal AB, and this entire network considered as a load. Okay, so that's why I have drawn this line and just show that yes, this is a load. So the question was, what is the value of this R? What is the value of this R so that this network will deliver maximum power to this load? Once again, please listen. What is the value of R so that this network will deliver maximum power to the load? Okay, maximum power to the load. So under that condition, you have to find the value of R. If you are not able to understand, once again I will redraw here. This is some network, okay, and this is your terminal AB. This is your terminal AB, and with this terminal some resistance and some voltage source is connected. Okay, so it is basically this as condition. Now I think you understand. So the question was, what is the value of R so that this network will deliver maximum power to this network? Okay, and it was a 2 mark question in GATE. Now we'll see how we find this. So what is our solution in this regard? Okay, now if we talk about the concept of maximum power transfer, so under what condition this load will deliver, under what condition, what should be the value of load so that it should be connected across this AB so that this network will deliver maximum power. So once again I am redraw this network, okay, and I am finally say that some load, we don't know what is that load, so say it is AB and say this is R. So this network will deliver maximum power to this load R only when this load resistance is equal to the Thevenin resistance of that particular network. Now if you see here, it's a kind of Thevenin equivalent. See, I should draw it in this manner also. This is very simple. This is 2 ohm and this is 10 volt and this is your current I. Okay, and now again this entire load is connected. So under what condition the maximum power will be transferred here? Okay, so under that condition I am calling that resistance as load, that is our RL. So if RL is 2 ohm, which we have already seen that RL1 is equal to RTH, under that condition this entire network will deliver maximum power to the load. So can you find the value of I for this condition? Yes, the value of I comes to be what? That is this voltage divided by these two resistance. So you can say it is 10 upon 2 plus 2, or you can say it is 10 by 4, so that comes to be 2.5 ampere. So this is our first solution. Okay, so it means the value of I is what here? The value of I is here as 2.5 ampere. So once you know the value of I, that is 2.5 ampere, you have just solve the first part of this question. Okay, so once again I will explain you here. When a load resistance of value 2 ohm is connected here. Why we have taken it as 2 ohm? Because once these two resistances are equal, you can say this source will deliver, this entire source will deliver maximum power to this load. So if you put 2 ohm here, you can easily able to find the value of I, and the value of I is what? 2.5 ampere. So this value of current is what? It is basically 2.5 ampere which is flowing, so that whatever the load, now this is your load, actually this is your load. So in this condition, this 2.5 ampere when flow in the circuit, it deliver maximum power to the load. Okay, now when you know the value of current, and this current is flowing under a condition when this network is deliver maximum power to the load. Okay, so should we say, now as I said earlier, this current I 2.5 ampere is flowing in this circuit, and this is the current under which this network will deliver maximum power to this load. So you can say that with this as condition, that is I 2.5 ampere, one can easily able to find the value of R. So I am simply applying one loop here. So it is 10 minus of 3, that is equal to 2 plus of R into 2.5. Yes, 2.5 is your current. Okay, or you can say 7 upon 2.5 is equal to 2 plus R, or you can say R plus 2 is equal to what? It is 2.8, or you can say R is equal to 2.8 minus of 2, that comes to be 0.8 ohm. So now the value of R comes to be 0.8 ohm. So finally you can say that the value of I is 2.5 ampere, and the value of R is what? 0.8 ohm. Okay. So this was the question of gate, and very simply we have just solved this question. Only the important thing is we have find the condition of I under which the maximum power will be delivered, and with the help of that condition, finally one can able to find the value of R. Please keep in mind, this R is not a load resistance, this is entire a load resistance. Okay, with this problem is finished. We move on with the next problem. We go for the next problem. Okay, so friends, this is our next problem. In this problem, you have to find the value of R. In this problem, you have to find the maximum power transferred to the resistance R. What should be the maximum power transferred to the resistance R? Okay, it means you can say that you have to find the value of maximum P max across R ohm resistance. Okay, so you have to find the maximum power across R ohm resistance. This was the question. So when you have to find the maximum power, we know the formula for finding out the maximum power is VTH square upon 4 RTH. Okay, so first you have to find the value of VTH, and then you have to find the value of RTH. Means you have to find these two values. And since we have to find across this R, so this R is basically your terminal. R will become what? Your terminal. Say it is A, it is B. Okay, and finally one can able to find the Thevenin equivalent looking in this manner. Okay, so I will redraw this network. Please see, I will redraw this network. This network comes to be what? That is, now you see, you have to find your equivalent at this terminal AB. Okay, so now this is your actual circuit. So now first of all we will find the Thevenin's resistance. So as we all know that how we find the Thevenin resistance, by making all voltage source as short circuited and current source as open circuited. So once these source get short circuited, okay, so this is your 2 ohm resistance, okay, and this is your 3 ohm resistance. So what is the condition? What is the condition? We will see. We will redraw this network. So once it gets short circuited, so directly you can say that this 3 ohm resistance, okay, and here it is 2 ohm resistance, and here it is your 5 ohm resistance. Okay, this is the condition. So as there is no dependent source, one can directly able to find the value of RTH, that is your Thevenin's resistance. This is your Thevenin's resistance RTH. Okay, so your 5 and 3 is in series, so I can directly redraw this network. This is your A, this is your B, this is 2 ohm, and this 5 plus 3 comes to be how much? It is 8 ohm. So what is your RTH? RTH is 2 parallel of 8, so that comes to be 2 into 8 upon 2 plus 8, so that comes to be 1.6 ohm. So this you have find the value of RTH. So finally one can get the value of RTH as 1.6 ohm. Okay, so this is the value of our RTH. Just keep in mind. Okay, now we have to find the value of VTH. So when we have to find the value of VTH, we simply find the voltage across this terminal. Okay, so what is the voltage across this terminal? I will say that voltage is VTH. That is your Thevenin's voltage, or you can say it is an open circuit voltage. So finally you can find the open circuit voltage. Now how you find? Either you just convert it and take a loop. Easily you can get the answer. So I'm redrawing this network here. Please see how it is, how it looks like. So I redraw this network here. Now please see. This 20 volt 3 ohm, we have to find the VTH. Simply it is in series, 2 ohm, 10 volt. I have applied here source transformation. Okay, here I applied the source transformation technique. Okay, for this network I have applied the source transformation technique. Okay, so here it is what? Source transformation. Okay, so now how we find the value of VTH? If this is the current I should consider here, so one can easily find the value of VTH. So how it is? See, minus to plus 20, I am just applying one KVL here. Okay, and we'll consider that some current I is flowing. So it is minus to plus 20, minus to plus 10, that is plus, and again it is plus, that comes to be 30. That is equal to 3 to 5. So how much it is? 10 into I. So finally it is how much? 60 is equal to 10I, or the value of I comes to be how much? It is 6 ampere. So the value of I comes to be 6 ampere. So what is your VTH? Now you apply one loop here. Please see, I am applying another loop here. Okay, for finding out the value of VTH. So the value of VTH, how much it is? Minus 2 plus VTH. Minus 2 plus VTH. Okay, again minus 2 plus, that is 10, is equal to 2 into the current flowing is I. So that comes to be 2 into 6. So you can say that the value of VTH comes to be 12 minus of 10, that is 2 volt. So this is your value of Thevenin's resistance. So now you find the value of VTH is equal to how much? It is 2 volt. Okay. So now you know the value of VTH also. So RTH you know, VTH you know, one can easily able to find the value of maximum power transfer. So the maximum power transferred is what? VTH square, that is 2 square upon 4 into your RTH, and their RTH is what? It is 1.6. So you can say it is 1 upon 1.6, or it comes to be how much? It is 0.625 watt, or you can say it is 625 milliwatt. Okay, this is your value of maximum power delivered. 0.625 watt or 625 milliwatt. Okay, so just by repeating, please try to understand. We have applied Thevenin's, then we have applied KVL, then we apply the concept of maximum power transfer, and finally we find the value of VTH. Here one more important thing is, since we have find the maximum power transfer, the value of R, that is load, is what? It is basically 2 ohm. Yes, because R become equal to RTH, under that condition only the maximum power transfers occur. So you can say that the value of R when 2 ohm, then only in that condition the maximum power will be delivered. If you want, I can draw this circuit also, this equivalent also. Please see. Here basically you have find VTH and you have find RTH, and this is your terminal AB. This is your terminal AB where this R was connected. This R. Okay. So you get the value of VTH as 2 volt and the value of RTH as how much it is? The value of VTH is 2 volt and value of RTH as 1.6 ohm. Not 2 ohm, it is 1.6 ohm. So once the value of R and RTH will become equal, under that condition the maximum power will be delivered by this network to this load. Okay, with this problem is finished. Now friend, this is our next problem. In this problem you have to find the maximum power delivered to this variable resistance R, or you can say maximum power for the variable resistance R. Basically, if I say this resistance is connected here, and we say let these two are A and B terminal. So basically what this network delivered the maximum power to this resistance R, that we have to find. Very important question. This type of same question was asked in GATE also, again 2 mark question. However, it looks very complex because again there is a kind of bridge network which is coming here. Now, as I explained you in my previous video about the balance and unbalanced condition, and if you see here, just you first of all you analyze whether the bridge is balanced or not. So just by multiplying this cross resistance, you can see it is 50 and it is 500. So the bridge is not balanced. So concept of balance condition of bridge is not applicable here. Very important thing. Okay. Now, so how we will solve this? So yes, I can say that we have to basically find the VTH and RTH for this resistance. Okay. And when this RTH will become equal to this particular R, the maximum power will be delivered. Or I can say that maximum power is what? It is VTH square upon 4 into RTH. Yes, very simple. Now your task is to find the value of VTH as well as RTH. Now when we have to find the value of RTH, once we look here, okay, so I am redrawing this network. When we have to find RTH, your all independent sources goes off. So your voltage source goes off. So, and this will become open. So now your network is what? Please see. Now, when this is short circuited, this this terminal. So should I draw here to here one line? Yes, this is the line. Okay, this is the line. If for the time being I call it as say x and y, so this is your x and y, just to understand. So x and y get short circuited. Why? Because it is short circuited. This is open, so I have just taken it out as out. So it is A and B. Now you will see if I again redraw this network, so this network comes to be what? It is basically you can draw in this manner also. Very simple. This is your AB. Okay. This is your 10 ohm. This is 20 ohm. This is 25 ohm. And this is 5 ohm. However, in my previous video, I have already directly given you the formula for that, but just for your understanding purpose, I am solving this entire network here. So your RTH across terminal AB is what? Basically, the parallel combination of 10 parallel 20, 10 parallel to 20 plus of 25 parallel of 5 ohm. So that comes to be 10, 20 divided by 30, 10 plus 20, okay. Or you can say here it is 25 into 5 upon 25 plus of 5. So this is also 30, this is also 30, so that comes to be 200 plus of 125 divided by 30. Or you can say it is 21325 divided by 30. How much it is? So this is the value of RTH. Now we find the value of VTH. Okay. Now see how we find the value of VTH. RTH you just keep in your mind, that is 10.83 ohm. The value of RTH comes to be 10.83 ohms. Now you have to find the value of VTH. Okay, the value of VTH. We will see how we find the value of VTH. Now I am redrawing this network. Now here we find the value of VTH. As I said, VTH is the open circuit voltage across the terminal AB. So I have just mentioned it as open circuit terminal VTH. And here it is 10 ohm, 25, 20 and 5, and this is your 60 volt source. Now as I said, VTH you can find is basically VTH is what? It is a voltage difference of VA minus of VB. Yes, very important thing. So if you find the value of VA and VB, one can easily able to find the value of VTH. And in my previous video, I mentioned you how we find VA and how we find VB. So we will directly see, we will directly find the value of VA and VB. The value of VA comes to be what? VA is the potential across this 20 ohm resistance. So that comes to be 20, this upon 20 plus of 10, that is into 60. Okay. This resistance upon sum of these two resistance into this voltage 60. Okay. Similarly, when you talk about VB, it is 5 upon 5 plus of 25 into 60. This resistance upon sum of these two resistance into 60. Okay. So how much it is? If I talk about VA, how much it is? It comes to be 20 into 60 divided by 30, that comes to be 40 volt, and VB is equal to 5 into 60 upon 30, that comes to be 10 volt. So the difference of VA minus VB, that is 40 minus of 10, that comes to be 30 volt. This is your value of VTH. So you have find the value of VTH also, you have find the value of RTH also. So can you able to find the value of maximum power? Yes. So your maximum power is what? Your maximum power P max is equal to VTH square upon 4 RTH, and that is VTH is what? That is 30 square upon 4 into RTH is what? That is 10.83 ohm. So how much it is? That comes to be 20.77 watt. This is the maximum power which is transferred by this entire network across the resistance. It means to the resistance R, that is across the terminal AB. Okay. So this is your next problem, in which we have seen it is a kind of unbalanced bridge, and under this unbalanced bridge condition, how we easily solve and find the value of RTH, VTH, and finally find the value of maximum power transfer. Okay. So with this problem is finished. Okay.